Hello, everyone. Good morning, good afternoon, good evening, wherever you are, whatever your time zone, welcome. This is AI Talk, and I am your host, Kevin Crane. Welcome to the show. Today, we will be discussing the topic of how industrial AI is reshaping electronics design. Artificial intelligence is driving a fundamental shift in how electronics are designed, tested, and optimized. AI is helping engineers move beyond traditional limitations, accelerating development, improving precision, and enabling entirely new forms of innovation. In fact, according to McKinsey, companies that embed AI into their product development workflows can reduce time to market by up to 30% while improving design quality. So today we'll be exploring three key areas for transformation. First, we'll explore how AI is revolutionizing hardware and development and prototyping. AI-driven tools are enabling faster iterations, cutting weeks or months off traditional development cycles. Next, we'll look at the use of reinforcement learning to eliminate human bias and optimize system design. Reinforcement learning helps uncover novel, high-performing configurations that human intuition just might overlook. And finally, we'll examine the role of AI in the future of engineering design and workflows. As AI becomes more integrated, it is redefining engineering roles and the skill sets required for future-ready design teams. So we're going to dive in just a moment, but first I want to say thank you to everyone attending today, and that include you folks joining us on LinkedIn. Hello, everyone, and hello, everybody joining us on Zoom today. Thank you so much for being with us. Today, we'd like to invite you to participate as well. We want to encourage everyone today to join in. So join in with your comments in the chat section, and if you have a question along the way, just jump on in. I will attempt to get some of your questions into the flow of the show today, and we may have a few minutes also at the end for your questions. All right, let's jump into our session today with a great panel of guests, starting with Sergey Nestorenko, CEO of Quilter. Sergey, are you with us?
Yeah, thanks, Kane.
Hello.
Kevin, nice to meet you, everyone.
Hello, Sergey. It's great to see you. Thank you for joining us. Where are you calling in from today?
Los Angeles.
Los Angeles. Excellent. Wonderful. Great to have you on board, Sergey. Also joining us today is Pontus Fonteas, Executive Design Director at GAC R&D. Pontus, are you with us?
Yes, indeed, Kevin. Thank you for having me. A pleasure to be participating with so many, hopefully, viewers and listeners, and not to mention least but last, the distinguished panelist. I'm very humbled in this genius company. So thank you for having me.
Well, thank you, Pontus. It's great to have you with us. Also joining us today is Anand Mirji, Director of Hardware Engineering and Architectures at Kornami. Anand, are you with us? Where are you? There you are, Anand. Where are you calling in from today?
Good morning, everyone. Good morning, Kevin. I am doing very well. I am calling in from San Francisco Bay Area. Very glad to be here, and thanks for having
Very
me.
good. Wonderful. Well, Sergey, Pontus, Anand, it is great to have you with us. Look, I'd like to start a discussion today by directing our attention to an article published recently by EE Times titled AI's Impact on the Electronics Industry. The article talks about how AI is transforming the electronics industry in manufacturing. AI-equipped sensors and computer vision improve autonomy and efficiency. Power electronics benefit from predictive optimization. Neuromorphic chips enable low latency, brain-like power for tasks such as motion detection and fault identification. But I'm curious from our panel, how are you seeing these trends play out in your work? And what are the most exciting breakthroughs happening right now? Sergi, what do you think about the article?
Yeah, thanks, Kevin. Yeah, obviously a great article. I appreciate the reporter putting that together. I think it highlights a lot of the areas where AI and neural networks are making an impact, which is basically, according to the article, everywhere. That's true. Every bit of firmware, every bit of code is being touched. I think that the one thing I would add to it, though, is a lot of what the article focuses on is kind of evolutionary rather than revolutionary, right? So it highlights a lot of cases where we do anomaly detection or accelerate some, development workflow in ways that kind of have we tried before neural networks and AI. And I think I would encourage the authors and also just ourselves here to think about like what could this be in 20, 30 years, right? What can we do with actually fully intelligent human robots that can reconfigure an entire factory for a new product in a couple of hours? Something radical like that, because I think those things will happen. And to me, I find those even more exciting than kind of better versions of things we are already doing.
Well, we may dig into some of those trends as we move along. Pontus, I'm wondering what your thoughts are on the article. How do you see these trends playing out?
Yes. So thank you, Kevin. It's a very good question, especially to me, because I'm the little odd bird in this company, in this area, since I'm a car designer. And I'm either coming in when we speak about UX and UI and before and the human interaction with the machine and how we can build models of that using AI, or, and more specifically, how do we use AI for our aesthetics? And that's a completely different, I would say, part of AI and how we humans are perhaps, more aesthetical, and we have trained our eyes through thousands of years. How do we learn a machine to see that in the same way? Now, when we speak about intricate surfacing and very complicated, what we're using, Alias and other 3D programs, it's not that easy for AI to actually comprehend and to understand what we are seeing. So that is the interesting part for me. So again, I'm a little bit offside on this one, and I'm going to try to steer this in a more soft and human-centric way. But I think I complement the panel with a little bit of that wisdom or my insight on it.
All right. Well, very good. We'll appreciate that. Now, Anand, what are your thoughts on the article? Where do you see the most exciting breakthroughs happening right now?
Well, Kevin, thanks for the question and great article. It touches a lot of things that are happening in the world of AI. And it's one thing to clarify, in the world of AI, there are a lot of things happening. One is LLM, is not to confuse with just the LLM part or chat GPTs or whatever that the interfaces that are coming up as only the AI. People tend to confuse that. But there are LLMs, there are machine learning models, there are reinforced learning, there are agentic AIs. So all these things are actually disrupting the EDA, electronic design automation industry as we speak in our world, which is the chip design, and is up for disruption. And where we stand today is early stages, very we are touching, just scratching the surface of it. And the fully autonomous way of chip designing is the way it's headed towards. And maybe in 20, 30 years, who knows, we may have a spec which goes into an AI system, out comes a GDS, which is a chip. In our lifetime, if we are able to see that, that's a breakthrough in the whole chip design. So that would be an exciting world to live in. And right now, what's happening is nothing less than exciting and encouraging for everybody. Yeah.
The article is AI's Impact on the Electronics Industry, published by EE Times. There is a link here in the chat feature, everybody. Let us know what you think. Take a look at the article. Is it missing something important that we should also be considering? And where do you feel are the most exciting breakthroughs happening right now for you? All right, well, gentlemen, I'd like to move us into our main discussion today, and starting with our first discussion point, how AI is transforming hardware development and prototyping. AI is significantly accelerating hardware design cycles by automating tasks like circuit layout, simulation, and validation. According to Deloitte, AI-driven design tools can reduce development time by up to 20 to 30% across electronics and semiconductor industries. Sergey, from a CEO perspective, how is AI helping your teams reduce development cycles or gain efficiency in product iteration and testing?
Sure. Thank you for the question, Kevin. So from our perspective, we primarily work with hardware organizations directly to help them accelerate, right? And so we use, artificial intelligence and neural networks in every part of what we do. And for us specifically, it's this focus on how do we accelerate the design of circuit boards in particular, right? So taking circuit boards from kind of a concept stage where you're describing what they should be doing and what parts they should have and how they connect into an actual blueprint that can be made. This is kind of the analogy analogy of what Anand already alluded to in what we want in chip design, which is, high level description to a GDS file all in one go. And I think perhaps in circuit boards that might even be a little bit closer than it is in chip. And so that's the main focus for us and the customers we work with, is to compress that time that it takes to design these boards, right? The biggest challenge for customers is that it takes many, many months to design a practical circuit board. And with the potential of full automation, it could be dropped to hours, which is, of course, a big change into the pace of development.
That could be a game changer.
Yeah, indeed.
I mean, from months and months to hours, that's impressive. All right, well, Pontus, as a design leader in the automotive space, how is AI influencing early stage hardware design and concept development in your field? And how do you feel it shapes that creative process?
It's a very good question, and again, my take on this is a little bit different. I will try to evaluate or explain as short and concise as I can. Now, if we look at developing a car, it's gone from lead times to 5 to 7 years down to 36 months and even below that. So we can see that there is a demand to have products and SOB much quicker than before. Now, is quality necessarily going to lack of that kind of quick time? I don't think so. Do we have less time to design it? I don't think so either. If we look at the American car industry in 59, 60, 61, whatever around there was a new model every year, right? Maybe the chassis, maybe the engineering was not new, but the whole bodywork and interior was the same. And we come to about the same kind of terms here. What is the tricky part of this is that a lot of things, when it comes to development and engineering, obviously, when we deal with AI, statistics and probability, you can really easily measure it and you can see the benefit. You mentioned 30% kind of, faster development time from, early in your introduction. Now, is that efficient if it's a lack of design input? So when we ask AI to design a car, it's obviously not that easy because it will take whatever is out there. Obviously, the human brain, we are also, of course, affected by what we see around us and what we've seen and what is a trend. But there is a little gut feeling there. There is this little sensation when you join artistic and more, I would say, you need that little creative artistic catalyst to get in there and to actually create something which is new. And we see it in art, we see it in music, we see it in theater, we see it in literature. Now, these are areas where AI at this point, because I don't say that it can't, there's examples of AI doing oddities. We had this Korean game, The Go, where it made like a strange thing, which was absolutely bizarre. And it just showed much later in the game that was the really what made this champion to lose the game. So I'm not saying at this point, but I'm saying that we are using AI to be efficient in certain parts of our process, and I may come back to that, but I give you a little teaser on it. So thank you.
Well, we've been bouncing around a 30% improvement in cycle time. Do you find that to be the case? Is it more or less?
I mean, going from working from European car manufacturers to American now to Chinese, there's no doubt that the Chinese are super quick in developing, right? So that is a pressure on me and my team and everyone that works. My kind of thing there is to safeguard the high aesthetics and the good values and not just being accepting that we have a product that is not worthy, it's not sustainable, or has something to add to our landscape, right? Because that is our responsibility. In all other kind of aspects, I really welcome and embrace where we don't have to do this tedious kind of thing and you don't see it. But when you do a box, it's not so hard to understand that you get it a little bit smaller, a little bit better package. But when it comes to a vehicle, it's a little bit different because it's still emotional, not for everyone, but for many people.
Now, Anand, what are some ways that you're seeing AI accelerate or streamline hardware, particularly high performance or specialized in specialized computing architectures?
Well, thanks for the question, Kevin. So the whole AI paradigm has completely fundamentally has been reshaping the way we have been doing the hardware design. Chip design especially is a very complex task, and it takes months and months of iterative design cycles and to come to terms. And it's a lengthy process. And the way AI has reshaped it is just not by replacing engineers, but also augmenting them in a way that we are able to do better design cycles right from concept to all the way to production, be it what we call RTL generation, where it helps in RTL generation, optimizing floor plans, thermal aware or power aware floor plans, which it can do from vast set of data that it can analyze on, and decisions which previously took months for several engineers. It can do it automatically within like few hours just by a tool, one engineer, and that's a huge cost saving. Verification is one of the biggest challenges in chip design. No amount of verification is enough. We always say, I want to do more. We never sign off on that. But here comes AI, and it can, identify these corner cases and come up with a regression set of suites, and then, help us find coverage closure. And that's a huge win, and which was previously, intractable. So furthermore, at a system level, when we look at co-designing hardware and software, then putting all the systems together, what we call the left shift, AI has been a big helper in all those things, especially in AI accelerators and codec related or edge related hardware interfaces, both in data centers and in edge IoT applications. We have seen we do a lot of co-simulations, and AI is able to tremendously fast track that by doing a lot of AI feedback loops, and this is completely going to reshape the industry.
Anand, you mentioned verification is the biggest challenge in chip design. Can you tell me a little bit more how AI is helping with that? Is that with the core simulation that you mentioned?
Yeah, there are multiple layers to it. So like I said, there is an agentic approach in which the tool can go through the code and run some basic simulation and find out that there is a bug in the code, and then come back and try to fix it, and then come back and rerun the simulation and say, oh, it passed. And this gives a recommendation to the designer, this is the bug, and then go fix it. The other aspect is we have coverage holes. There are 100 lines of code. Out of that, about 50 lines are hit. Another 50 lines are not hit, or rather 90 lines are hit, 10 lines are not hit. It can come up with test cases where those 10 lines can be hit. And then it can help us design verification engineers to close that coverage. And that brings us to about 100%, 99% of coverage closure. That's a huge win. Regression closure, regression debugging. And furthermore, it can parse through the logs, which designers or verification engineers often overlook, and then say, highlight specific warnings or errors, and then say, I want to fix this. And then it can interactively go and fix it and come back and then I fixed it. So it's a huge win in that sense.
All right, we are here today with Anand Mirji, Pontus Fonteas, and Sergey Nestorenko. We are here talking about how industrial AI is reshaping electronics design. And gentlemen, we do have a question or a comment coming in from our audience, and this one's coming in from Dan. Dan, thank you so much for your contribution today. We really appreciate it. Dan is asking, how far away are we from AI being able to independently design and prototype hardware systems without human intervention? I'd like to open it up to the entire panel, but Sergey, what are your thoughts for Dan on this?
Yeah, Dan, thank you for the question. I think we have to define to what scope basically this question applies. So obviously I'll speak just to circuit boards because that's what I know best. I'll leave the experts on the panel to speak to higher and lower level designs. But within circuit boards, I think the main question is how complex of a circuit board are you thinking about? I think that for a circuit board that's relatively non-complex, like something that a human could design in a day, say a microprocessor connected to a couple of sensors and some basic power circuitry, we're already there. right? There's already systems that will take that in from the human as a high level spec, saying, hey, I need a microprocessor reading a few sensors. There's AIs out there that'll design the schematic, that'll do the layout. And I think with no human intervention, like that circuit board will work. And so I think that, but of course, that's not true for like a computer motherboard, right? Certainly, we're not near the point where an AI could design that end to end. And so I think the key question is kind of mean time to error, right? If you think about what happened with language models over time, we went from kind of basic autocomplete in your email that could guess the next few words, to then getting pretty good at guessing the next sentence, to then, ChatGPT 3 guessing the next, kind of paragraph, to now code models that can go do like 10 minutes of work or so in software before making an error on average. And so I think in circuit boards, we're at the kind of 1 to 2 days level of mean time to error. So far from systems that take months, but definitely there and done for systems that take less than a day or two.
All right, very good. Thank you, Dan, for your question or your comment today. And folks, if you have a comment or a question for our panel, please just jump on in. We will attempt to get some of your comments and questions into the flow of our discussion today, and we may have some time at the end as well. All right, let's move on, gentlemen, to our next discussion point today, and that is eliminating human bias and optimizing system design with reinforcement learning. Now, reinforcement learning is a term that I'm not familiar with, so perhaps you can help me understand it. But the way I get it is it's enabling systems to explore massive design spaces and discover solutions that outperform those developed by humans alone. A recent NVIDIA study found that reinforcement learning-based optimization improved chip design efficiency by up to 25% compared with traditional methods. Sergi, what is reinforcement learning, and how do you see reinforcement learning help organizations like yours minimize bias in decision making and drive at more optimized data-driven designs?
Sure. So let's start with the first question of what is reinforcement learning. I think it's
Please.
helpful to kind of start with the simple analogy back to Go. I think Pontus, you already mentioned AlphaGo and Move 37, and I think that illustrates very clearly what's happening here. So the kind of more traditional type of machine learning that we're all familiar with and the way ChatGPT was initially trained is what's called supervised learning, where basically you show a neural network some input, you tell it what the human would have done, and you train it to produce what the human would have done. And that requires a large data set of examples of given this input, the human would have done this output, and the network should recreate it. Reinforcement learning is a fundamentally different way of training that neural network in that it's instead of using a human example as a signal to learn, it uses a score, right? So for example, imagine playing a game such as Tetris, and if you play the game and score poorly, then that set of actions is taught to not be replicated by the neural net. Whereas if you score well, then the neural network is adjusted to recreate those actions again, right? And so over time, it can do this billions and billions of times. You get really good at the game. And what, as Pontus alluded, what DeepMind found with AlphaGo over time is when they initially trained it just on human data with no reinforcement learning, they reached the performance that a really good human would reach, a grandmaster. When they fine-tuned it with reinforcement learning, they were able to beat the grand champion. And then it was the next year, in my opinion, that the biggest breakthrough happened, where they eliminated all human data altogether, trained only on reinforcement learning, and can completely crush any grandmaster out there and Go with absolutely no competition. And so I think that this is speaking to that second question that you asked about what the impact is and the result of eliminating bias, right? This reinforcement learning paradigm allows us to focus not on just a human saying this is good and this is bad, but on something like physics, right? Where we can train from a signal of, is this design actually going to work unambiguously with physics simulations or real world build as proof. Versus a human judging whether it'll work. And for design sense, I don't think that's appropriate. But for engineering and for making sure the product is actually functioning, I think it's a huge breakthrough in what will be possible, and it'll be the thing that enables AI to really penetrate in the hardware industries.
Now, Anand, I know you had something to add before I moved on, and I'm sorry that I moved on without getting to you. So, Anand, can you tell us a little bit about your thoughts about reinforcement learning, and please do comment with what you had in mind there a moment ago.
Thanks, Kevin. Yes, I wanted to, expand upon what Sergey was saying about, the question one of your listeners asked about how far are we from completely human, completely automated hardware design systems. We are still quite a ways away from it, and but to certain degree, it depends also on the system. We have seen small systems, the AI tools can now generate reasonably well-crafted code, and it's pretty accurate. It's about 95% accurate code with, reasonable amount of coverage, or test coverage on that. But the question is, do we trust that code and do we deploy that code? That's still a big question mark. And to be able to fully automate that and then take it autonomously, that's still a far away. In my opinion, it's at
Got it.
least 30 years away.
And how is reinforcement learning helping your engineering teams?
So that's an interesting question, Kevin. So reinforcement learning, one of the things about human intuition is it's both strength and bottleneck. So it's often guided by, legacy designs, legacy thinking. And so here comes the reinforcement learning, which is, often like, explained earlier, guided by, rewards and, penalties. And it's usually able to break that human bias kind of a loop. And reinforcement learning can optimize some of the parameters that we look for in designs, which is power, performance, area, and add to that reliability in unconventional ways and non-intuitive paths based on its data set and all the other things that it comes with. So it kind of takes away a lot of the human thinking in terms of we have been traditionally been doing certain things certain way, maybe organizational thinking, maybe mental block. It takes away some of those things. And what we have seen, the data which comes through every now and then is place and route, for example. Google's one of the place and route examples was through reinforcement learning. They were able to reduce the cycle of a large chip, and they were able to place and route within few hours, which would have taken a team of 7 about 6 months. So there is a tremendous amount of improvement that is happening with the reinforcement way of doing things. Yeah.
Now, Pontus, how can reinforcement learning support design teams in exploring unconventional or unexpected solutions, especially in industries like automotive where aesthetics and performance must align?
I knew this session was going to be mind-blowing and make us all think in different ways. I'm just going to try to kind of speak a little bit about the difference again, about aesthetics. We have, of course, it's very easy to measure efficiency. It will take 10 engineers to do all these calculations. I plug it in, AI will do it in a second. Right, I save so many hours. But when we speak about art, theater, music, designing a car, taking a photo, of course, there's things there that AI can illustrate, and we look at it and we say, yeah, that's pretty good. It looks fantastic. But how do you measure the initial idea? Because the idea is like that. Depending on the human experience, his or hers, how much they have been trained as AI, taking in all the human values. If we look at a tribe in Apaches or whatever in Africa, and how they can find aesthetics in very, very simple means, feathers, stones, or colors, or whatever. There is a fantastic beauty and aesthetics on that. Of course, all our culture heritage, we are having and we are shaping our future with that, right? So the thing is that for me as a car designer, the initial idea is what I'm after. And that is depending on so many things. It's random, it depends on the team, it depends on the day, it depends on what film you saw the day before, the discussions you have, how it just happens. And of course, you as a designer, as a creator, right? But the question that I'm going to illustrate this with a little example. If it's a true story or not doesn't matter. BMW did art cars, and they invited Andy Warhol and his assistant to come and paint the car. As the story says, again, I don't know if it's true, but it makes my point. The camera team set up, they were going to document everything. 42, 45 minutes, the car was ready. Now, we could have said it's going to take thousands of hours and 2,000 of hours, hundreds of hours to do the work that the artist and his assistant do it. And, like Andy Warhol, he didn't really spend any time. Jean-Michel Basquiat, not so much time on their painting. It's going fast, they sell for millions, whatever. The execution is not the same thing as the idea. And the AI, we see the win and the profit because we want to be efficient, right? Now, if we would have a completely different learning curve for the AI to create the aesthetics, because as I'm saying, we are very, very comfortable that all the aesthetics that we see, if we have houses, architecture, art, whatever, music, it's created by humans. But if we have AI taking over that pose completely, are we going to have a new aesthetics? Are we going to find what we feel is in harmony in a different way? That is the question here. If we train AI, and are we then going to accept that kind of aesthetics? So it's a cultural, it's a game changer what we're going through. How much? Because for me, when I have the idea, I try to use AI as much as I can. As same as I was in advertising in the 80s and desktop publishing came. You have a computer, you have Adobe, Photoshop, Illustrator, whatever. Now we have InDesign. Of course, it's just so much quicker to create what you want to do. The ideas is still here, but you didn't have to do it with scissors and pens and whatever. AI is really good at that. But I'm after that initial idea, and are we okay that AI now is creating the world that we know when it comes to culture and arts? So my take on it.
All right, we have another comment coming in from our audience, this time from LinkedIn, and I'd like to just open it up to the entire group, maybe just a quick response to this question. What does an ideal human AI collaboration look like in a modern electronics design team? Anyone?
I can take
Sergey,
that.
how about your teams?
Oh, go ahead. Go ahead, Sergey.
I'll yield to Anand. That's okay. Go for it.
Yeah,
Please,
I mean,
please go right ahead.
thanks, Sergey, and thanks, Kevin. We see this a lot, so that's what I wanted to jump on. So what we are seeing is a co-pilot kind of approach or semi-autonomous type of approach where the collaboration between a human and an AI tool is more turning towards a augmented type of design, where the designer defines the intent, the constraints, the goals, aka PPA, power performance area type of constraints, and the system produces results. And then it's an iterative loop, and the human intervenes in between, and then defines the constraint, and you produce a solution, and then the final sign off comes from the human. And this is kind of not a job replacement for the humans, but kind of an augmentation for the design, and it helps designers become better designers. Now, designer job is more to think in terms of architecture, system level, and bring in that intuition that Pontus was talking about, the art part of it, and combine a lot of other elements, just not the design part of it, but the human aspects into the design, and relieve the other mundane things for the tools and the AI to take care.
All
Yeah,
right.
if I may add just one thing to Anand's response, and it's a great response, Anand,
Get you,
is
Pontus.
that I think the hardest part that I see teams struggle with is understanding that which parts AI is actually good at today and which parts it's really bad at. And in general, as humans, we tend to overestimate how good it is at the things it's good at and how bad it is at the things it's bad at. And so I think it's you can't really use human intuition to say if I'm good at this, AI should be good at this, and if I'm bad at this, AI should be bad at this. It's actually frequently the opposite. And so I think the only thing I'll add is that the best teams are very actively experimenting with different AI methods and constantly updating their priors on what works and what doesn't every month, because that it's a moving target of what can AI do today, what can it not do, what can I trust it with, what can it not trust it with, and as you update that, you can make your workflow more and more efficient.
And Pontus?
Yeah, no, I want to pick up because here we are all in the same boat. And Sergio, you spoke about guessing a little bit before. And the thing is that for me, the AI takes away a lot of the guessing, right? And I'm not going to go through the long and tedious process how we design car and how it came up to the executives in the end of our creative process and they go pick A, B, or C. I'm not going to do that. However, what I can say now is I can take a design that I did like 20 years ago. I have a 3/4 front view, a 3/4 rear view of that design. I can, by putting into Kling, for instance, I can make that car move, and I can put it in everywhere in the world. I can make it go to Alaska, down to Ushuaia, and I can see my design more or less exactly. It's still kind of fighting a little bit in some transitions and too much angle differences, but I am blown away when I see that. So it takes a lot of the guessing out for everyone when we present whatever we do in our field of expertise. When we present it to a client, when we're going to see the result, we can see it without the guessing, without all the trust. You come into, you see the skyscraper, it's built, and they can say, I don't like this. Well, with AI, we take all of that also for ourselves. I see that is the best way, and that is, I think, the best way for us users, how we interact with AI, to be a little bit humble and also, use this tool to reinforce our thoughts and make it more visible, also for ourselves.
Well, that takes us right to our next comment coming from Teo. Teo, thank you so much for your contribution today. And again, I'd like to open it up to the entire panel, so please just jump on in, gentlemen. But Teo is asking, how do you think there's an AI design tool we could actually teach our own unique perspective or better our signature style so that in the end you can't even tell which tool was used, only that it's unmistakably pushing our individual style? Anyone have a comment or thought for Teo on that?
Yeah, happy to jump in. Teo, thank you for the question. The simple answer, at least as far as I'm aware, is no, I'm not aware of such a tool today, unfortunately. As I kind of reflect on the question, and it's a question that I hear a lot about, hey, can't I get the AI to do what I would have done exactly? So that I basically don't have to trust something new. I can just see that it's exactly what I would have done. In my opinion, it turns out to be actually an even more difficult task than just making an AI that makes electronics that work, because you have to first make an AI that reliably makes electronics that work and then has enough flexibility in its solution to tune it to look like your design. And so you've got to have enough data and training to make it kind of be able to solve problems first, and then to further constrain it to your style. So I think I don't know if it's going to happen. I think people will definitely try. I think there's an appetite for it, but I'm not aware of a tool today, at least in circuit boards, that is actually effective at doing that today.
I'm just saying hi to Tayo. That's how her name is pronounced. She's an awesome
Teo.
designer. I had the pleasure to work with her on several years. She is ex-Bugatti, Hyundai, Audi, and really, really interesting how she pushes the boundaries in her field. Tayo, I'm trying to work on it. The thing I can say is that through the VR that we started many years ago, as you are very familiar with, of course, we put the CMF, the materials, the colors very early in the process, and we can actually see it on a 3D, and we can open the doors from a car, and we can see how the inside and outside correlates. I use the AI for CMF, especially going from ChatGPT to create some mood boards and facilitate that kind of work. But we're not there yet as far as I'm concerned. So I agree with Sergey in what you have said. Are we getting there? I, I think, I'm looking at quantum computers. How far away are we from that? I don't know either. So, it's coming for sure, to have a more use of AI when it comes to that field as well. But nice of you joining us. Thank you so much.
And Anand, what are your thoughts?
Yeah, thanks, Kevin. And thanks, Ty, for the question. So the short answer is we don't have a specific tool right now, but is it in the works? Yes, it is. So just to give an illustrative example, when we do designs, hardware designs especially, we have design guidelines. And these are design guidelines built over several generations of chips, several generations of products, mistakes, learnings, etc. Which, the tool, one thing is what is available open source, which it learns by, but it also need to learn by the mistakes or the problems that the chips faced, which is very hard to create. So that's where this design guideline document acts as a feeder to these training models, and that's where it can learn from. And can it bring in a unique style for that organization, that company? Then you can kind of say it is, because it is the design guidelines is based on methodologies, the tools, and the way of doing things, the recipes, so to speak, that the organization or the company has applied. You can see the glimpse of that. If you today use ChatGPT and try to write your own style of experiences, it kind of has a memory which remembers it. And then if you prompt it enough to make it your own unique style, it kind of learns from your past experiences, past feeds that you've given, and then caters towards what you are. So it kind of becomes your own unique style. So in that sense, it is headed towards that. So it's not too far off, before we get there.
And it's very good point, Anard. It's you can actually get AI, and I have a colleague who stopped being so present on the web because there was through LibLib, they started copy his work and in his style. But Kevin, I don't know if this is our way to be immortal, to kind of continue with your style or your take in things in the future in cyberspace, so to say. But it is intriguing. But yes, we can get a digital copycat of ourselves today. Scary.
We will see how the future unfolds. For now, we're here with Sergey Nesterenko, CEO at Quilter, Pontus Fonteas, Executive Design Director at GAC, and Anand Mirji, Director of Hardware Engineering and Architectures at Kornami. And we are here. This is AI Talk. We're talking about how industrial AI is reshaping electronics design. And gentlemen, in the time remaining, I'd like to move us on to our third discussion point today. And it is about the role of AI in the future of engineering design and workflows. Sergey, from a strategic standpoint, how is AI influencing how you build engineering teams and structure projects or plans for the future of innovation at Quilter?
Yeah, it's a good question. Thank you, Kevin. I mean, I think we've kind of already touched on this a little bit with the impact that it's already making in electronics design. I think this is true everywhere, right? Like we have to constantly ask, what is AI now good at, and what is it not good at? And the most efficient path forward is to staff people where it's not good and to leverage it where it is good, right? And I think the only thing we know for sure right now is everything is changing month to month. Right. So I think the most important thing for right now is just to stay aware and stay on your toes. That's by far the most important thing. How exactly things will pan out, we could take many guesses. I have many hopes for different AIs starting to collaborate with each other between, mechanical and software and electrical and being able to negotiate between each other and things of that nature. But right now we just don't know. And so I think for us, the most important thing is just to learn, stay aware on at least a weekly or maybe at most monthly basis, learn about what new tools exist and check in on the old tools and see how much they've improved, because things change drastically.
And Anand, at Kornami, what lasting changes do you foresee in engineering workflows as AI becomes more embedded into hardware design?
Right, Kevin. Like Sergey mentioned, so there are several approaches being taken today for the hardware design development. Two that kind of are leading the way is one is the agentic approach, where you give a set of goals and it goes off and does its job. And then there is a co-pilot where it acts as a partner for you, kind of a peer while you're doing your stuff, and then suggests corrections while you go. Agentic is kind of leading a little bit further into this. So where you have all these different aspects of design like RTL development, verification, layout, floor planning, etc. All these things, the agentic approaches can help do better job of optimizing at much lower cost, much faster time, and all those things. So the future of AI, what we see is semi-autonomous, like we said, and also it's more of a design augmentation where designer feeds in the constraints, and the AI tools optimize things with the human in the loop. And what we see going forward is it elevates the designers to become better designers and take up higher levels of abstractions. And what would be interesting to see is how the humans can act as a bridge between what unique aspects, human aspect that they can bring to what the AI tool can do. And they can bring this unique bridge in between them and create something which the tools or the human cannot create. Yeah.
Now, Pontus, at GAC, looking ahead, how do you envision AI reshaping the relationship between human designers and machines in creative and technical collaboration?
Mm, I'm going to put the question a little bit more profound than maybe you put it, if I may. So we speak a lot about, and we all mention it, and Anard, you did it as well now, the efficiency, and we can make this faster and cheaper and whatever. And since we know, because we are smart enough to know that we are all replaceable, right? Everyone can replace us. Now, I'm dealing in a profession where other people judge my work. And I'm not making a decision. That's my executives that say this is a good design and we will produce it. We will invest all the time and money and let our factories produce what you has designed. I'm not the one who makes that call. This is executives. Now, their understanding of design, if it's the right one, if it's the correct, if it will be successful, it's what they have as responsible. That's their job. It's not mine. However, they can be wrong, but there's no way I can do that. Now, the tricky thing is that we come to certain AI where AI, it's very easy to see that AI is more efficient than a human being, and there's no question about, there's no doubt. But the higher you go in that, and the harder it is to actually to say, is it the right thing to replace this person, because it's all in the in the view of the eyes of the beholder. How proficient is he or her to judge that, right? And the thing is that someone may say, why do we have all these design departments all over the world? They cost so much. Pontus and his team is far too expensive. I can just use this, an executive say, I can do the branding, I can do the logotype, I can, just learning this kind of program. Look, it's like a fantastic car, and I did it. It's so easy that it happens. And then we lost this important, very important thing, is that when expert and very talented people are in charge of something and we use AI, it's a big asset, and we can do our work faster and quicker and better, and so on and so forth. The problem is when someone who can't really judge what is really good and okay take over that control, and that goes for all of us, all of us. So I think that is the little tricky part, when someone says we can do this without any designers. Look, and then you may come. I don't know. I can't foresee that is a bad or good. I'm just saying it's a risk that you lose something on the way. Because
Well, gentlemen,
I can
oh,
already see. I'm going to say that I was in Shanghai Motor Show not long time ago, and I can say that there's a lost art in ergonomics and quality in interiors. Everything looks the same almost now in the car industry, but there's things that are not human centric anymore because it's a lost art. We don't we don't have the same people. We don't have that knowledge. We lose a lot, and you lose something which is very, very important in that. and it's a risk. Sorry for that, Kevin.
Well, gentlemen, we have reached the action item round of the program. Where has our time gone? I'm wondering if each of you could please provide us with one quick action item that our viewers can use to take advantage of your ideas and advice. Anand, do you have an action item for us today?
Well, I don't have a particular action item, but I have a question to ponder for our listeners, and something for the AI community to think as we continue in our journey towards the AI development. As we integrate deeper into the AI realm, in the engineering world, are we using AI to amplify our intent, or are we letting it override our intuition? So something I would like everybody to ponder upon and guide the industry towards in that direction.
That is Anand Mirji, Director of Hardware Engineering and Architectures at Kornami. Anand, it has been great speaking with you today. Thank you for being with us today. Now, Pontus, do you have an action item for us?
I'm going to be very, very short. Um, it's not artificial intelligence, it's augmented intelligence, and it's not us versus AI. It's the human who learns how to interact and integrate AI as good as we can versus the one that choose not to. That's what I think the future will be.
That is Pontus Fonteas, Executive Design Director at GAC R&D. Pontus, thank you so much for being with us. It's been great speaking with you. And Sergi, do you have an action item for us today?
Yeah, I'll go kind of the opposite direction of the previous two. I think Pontus and Anand give great thoughts to think about. I'll be a little simpler than that. I would just recommend to everyone to go to ChatGPT or Perplexity or whatever tool that you like. Once a month, just ask it, what's new in my industry? And that's it. And if you just do that on a monthly basis, your curiosity will take you where you need to go in this space.
That is Sergi Nestorenko, CEO at Quilter. Sergi, Pontus, Anand, it has been great speaking with you today. What a great panel. Your perspectives and advice are spot on. Thank you so much, and I hope that we get a chance to talk again soon. And to everyone else joining us today, thank you too. Join us again next time on July 15th with a great panel of guests where we will be discussing the topic of leveraging AI in retail. That should be another great discussion. In the meantime, if you'd like to find me, you can do so on LinkedIn. I'm happy to connect there. You can check me out. I'm Kevin Crane. And you can check out my weekly audio podcast, the Digital Transformation Podcast. But for now, that'll do it for this episode of AI Talk. And until next time, I am Kevin Crane saying thanks for watching.